Yes,
visible,
sir.
sir?
Yes, it is visible. And you are also audible.
Okay, so dear all, this session is dedicated to different techniques for data acquisition and management in Internet of Things. And we will use different free and open source tools along with free and open source toolkits. We will see how to integrate cloud based applications for management of data related to IoT. In this session, we will try to cover multiple aspects of IoT, Internet of Things, along with their protocols, different communication protocols, file systems, by which way data is stored and managed. And as all of you are researchers, you are academicians, you might be working on different research projects, different simulation based projects or test based applications. Then how to integrate these applications. Okay, whether you are working on core IoT or its associated technologies like fog, edge, cloud, we have to work with different types of sensors in IoT. So everybody knows that as far as IoT is concerned, we work with different types of gadgets. And nowadays also, you might have seen for machine to machine communication, for device to device communication, different types of communication protocols and file systems are integrated. So we will see some flavor of sensor programming also. So to whatever part it will be possible in an online session, I will show by simulation, and we will see which protocols we use in IoT scenarios. As you can see here, MQTT is there, COAP, Constraint Application Protocol, Lightweight Machine to Machine Protocol, Advanced Message Queuing Protocol, Message Queuing Telemetry Transport. So we will discuss about these points along with some case studies, okay, where we have to use it. First of all, we will see as far as data acquisition, data management, data control related to IoT is concerned, in which cases we have to integrate it, in which cases we have to deploy it. For example, we want to go for some agriculture based application, we want to develop a GUI based dashboard. As in previous session, few examples were given related to agriculture domain. For example, we have deployed some sensors, Raspberry Pi based integration, Arduino based integration at some farming land. And but major part is that how to control it, how to view different aspects, how to view different readings. So that is the main thing related to data acquisition. So whatever data is transmitted, whatever broadcasting is going on, whatever readings we are taking from agriculture land, so how to integrate it with an Android app, how to create a GUI based dashboard. So this type of domain, dashboard for agriculture domain. So to some extent, I will show you in live demonstration also. So very soon, I will show you some free and open source toolkits that we can use for creation of these dashboards. So how to integrate weather forecasting, how to integrate Wi-Fi. So whatever Wi-Fi scenario you are having, so how to access its signals. Okay, but before covering any practical demonstration, first of all, we will see which are different use cases of IoT along with data acquisition, management, control, plotting, how to generate different types of graphs, and how to work on simulation part. Okay, for example, this type of scenario we want to create, then how to integrate it with mobile app. And major thing is that which protocol we have to use. For example, we have deployed some Raspberry Pi, we have deployed some Arduino board at a remote location, and in that particular open source hardware we have integrated some sensors. So whether we can integrate HTTP protocol, FTP protocol, or there is some specialized protocol. Okay, we will discuss about that part also, which specific protocol we have to work in IoT scenario. As far as toll plaza is concerned, FASTag toll plaza is concerned, you might have seen that. What is that particular uh, chip? Okay, that is small size chip, very small scale chip, and that is able to communicate with servers, and those servers are communicating with satellite or controller. So, which particular protocol is taking care of all of these things? So, all of these technologies are interrelated, whether we are discussing about IoT, artificial intelligence, embedded wireless. Okay. So, how to derive information directly from the source and with specialized protocol. For example, you are working on this type of research project, swarm drones. You might be working on some research projects. You might be applying for some project tasks to funding agencies. For example, we want to integrate this type of scenario. Okay, so in between the session, there are some messages. So some participants raising hand. Kindly confirm. Any question up to this point? Any query? Are you getting audio and screen properly?
Yes, sir. Audio is okay.
Okay. Okay. I request all participants to keep their queries so that at end of the session we can discuss each and everything. In between the session, it will be difficult to take your queries because the contents may be skipped. So in last 10 to 15 minutes, I will take everybody's questions if you are having. Okay, so first of all, I will cover the content as per the schedule and whatever is planned. And at end of the session, we will discuss about your queries and doubts. Okay. Now, so for example, this type of research project you are working for law enforcement. Okay, drones, whether it is for law enforcement or we are working for military applications, swarm drones. So for this type of implementation, which specific protocol we have to use? For example, this one. Okay, FASTag implementation, intelligent applications for agriculture. So if we want to create a particular dashboard, if we want to create a specific web-based application or desktop-based application that will be able to read each and everything from remote sensors, then which toolkits are available? And major part is that which specific protocol we have to use. Okay, for industrial automation, for smart ambulances, lots of use cases, lots of examples. For example, we are working on smart ambulance. So in smart ambulance, where is use case, where is integration of IoT? As if patient is moving in a particular ambulance and at remote location, some medical practitioner, some medical expert we want to communicate. So whatever readings are there, whatever readings, whatever measurements are associated with the patient, these should be broadcasted, these should be transmitted to remote medical expert. Okay, and accordingly that specific action should be taken so that that particular patient can reach the destination safely. Okay, so in this particular scenario also we have to use very lightweight protocol as well as file system for data acquisition, management, storage, plotting, and even on that particular data we can implement machine learning, you can integrate deep learning, you can go for data analytics part. Okay, robotic surgery, smart health services, telemedicine. So all of these applications, all of these use cases are associated with IoT along with advanced wireless protocols, whether you are working on 5G or 6G. Nowadays lots of research is going on in 6G also. Okay, so 6G along with IoT, smart health services. Now we will see which platforms and toolkits are available for simulation of these implementations. If such type of implementations we want to perform, we want to integrate for our research work, then which platforms we can use and which specific protocols we have to work with. So these are few frameworks we have mentioned, and beyond these also so many other platforms we can integrate. But before that, we will see which specific protocols we have to use in this particular case. Okay, mosquito. As far as IoT programming is concerned, as far as IoT implementations are concerned, which specific file system and protocol we have to use, whether you are going for simulation, emulation, test bed, or real world sensors. MQTT brokers, Mosquito MQTT broker. Now, what is MQTT? First of all, we will see what is this particular MQTT we are discussing here. MQTT, that refers to message queuing telemetry transport. This is the key protocol used in IoT. Okay, so I'm showing you that particular part. So this one, sensor interfacing. Whether you are working for law enforcement or you are going for implementation related to agriculture or medical domain, telemedicine, or um, e-governance or social applications, generally what we do, we take a particular open source hardware, Arduino, Raspberry Pi, BeagleBone Black, whatever it is, and with that particular board we integrate some sensors, humidity sensor, temperature sensor, or whatever it is, different types of fume sensor, gas sensors. But major thing is that these sensors are low powered devices, low powered, low resource devices. That is the main thing associated with IoT. In IoT, we generally work with low power, low resource devices. So how to communicate those low power devices to a satellite, how to integrate it to remote location? So for that particular implementation, we use MQTT protocol, message queuing telemetry transport. This is the main protocol for data acquisition, data transmission. Okay, so we will start with this particular part. As far as FASTag toll applications are concerned, you might have seen in our vehicles FASTag is there. So what is that FASTag? That is a SIM card size chip. That SIM card size chip, that very small size chip, is able to communicate with a specific station, base station, okay, or we can say that toll plaza. It is communicating with that. As soon as it is communicating, it is coming in range of that specific uh, base station, it will perform some action, okay, whether that action is related to taking images or it is related to payment gateway or whatever it is. Okay, but major thing is that which is that protocol, that is MQTT protocol. In case of IoT, we do not use classical web-based protocols like HTTP, FTP, Telnet. Why? Because classical web-based protocols, these are very heavyweight. Heavyweight means we, for example, we want to integrate HTTP in Amazon Alexa. Obviously, we need one HTTP server, one HTTP client, and obviously it will be a heavyweight application. It will be a huge application. If in case of Amazon Alexa also, MQTT protocol is used. In case of Siri, in case of Google Assistant, in case of Amazon Fire Stick, nowadays in many implementations in many homes of Amazon Fire Stick is used. Okay, so which is that particular protocol? A very small size handheld device is able to communicate with a particular device with another gadget. That is MQTT protocol. So this thing we should be very much clear. If we want to work with IoT implementation, IoT simulation, emulation, test bed based application, or real world application, in every scenario we have to work with message queuing, telemetry transport. This is the key protocol. Whether you want to go for smart home, smart office, smart city, or whatever it is. Okay, so whether you are working for e-governance based application or smart vehicle application or toll plaza or agriculture, in every case we have to use MQTT protocol. Now we will see how to deploy it, by which way we can work on this protocol, and to some extent by how to view its working scenario. Okay, so in this way, at back end of these implementations, there is message queuing, telemetry transport. Okay, for example, I want to work with this particular protocol in my laptop. I want to work on smart home automation or smart office automation. For example, in our surrounding, I want to connect each and everything with my mobile phone, like washing machine, refrigerator, LEDs. I want to communicate, I want to integrate each and every nearby device with my mobile phone, Android based phone. Then how to do it? For this type of application, first of all, we need MQTT software, because we are obviously, if I am working on smart office automation or smart home automation, it is associated with IoT. If I am working on IoT, I must need IoT software. Which is that IoT software? MQTT broker. And from where I will get that MQTT broker? Lots of toolkits available under free and open source distribution. Mosquito is one of that. Eclipse Mosquito, Hive, HiveMQ. All of these are completely free and open source. Okay, for smart home automation, for smart office automation, for personal use. Okay, you can work on these software. For example, you want to go for industrial automation. Okay, Eclipse Mosquito, another software. Rabbit, RabbitMQ. Okay, so if we want, for example, from my mobile phone, I want to control my vehicle, whether it is bike or car. So obviously I need IoT software. So in very layman's point of view, in very simple way we are discussing here, if I want to work on IoT, definitely we need IoT software. Which is that IoT software? MQTT is that software. From where I will get that software? Either I will download it from RabbitMQ or mosquito.org or HiveMQ and hundreds of other toolkits available. Okay, so not only these, hundreds of other toolkits available. You can directly search on Google free MQTT broker. So you can see it is completely free and open source. Okay, RabbitMQ. So as soon as I will download and install any of these software, my device will become IoT broker. I'm repeating this point. For example, I download this software in my laptop. After downloading and installation of this software in my laptop, my system, my laptop will become IoT broker. And with that IoT broker, I will be able to connect my washing machine, microwave oven, or vehicle, or whatever it is. If it is sensor integrated, obviously it should be sensor integrated. It should not be analog. Okay, it should be digital. Are you getting what we are discussing here? Kindly confirm. Up to now, whatever we are discussing, Are you getting these things in chat window or by audio? As far
Yes,
as
sir.
understanding is concerned, whatever we are discussing, are you getting?
Yes. Yes, sir. We are getting and we are understanding.
Okay. So other participants are also responding. Okay, fine. So in same way, for example, say this software I download and install in my mobile phone, whether it is Android or Apple, my smartphone will become IoT broker. Now we are using a term broker repeatedly. What is this broker? So here also it is written MQTT broker. We will understand this particular term. But MQTT, we are clear that it is the protocol. We can't work with HTTP, we can't work with FTP in IoT. As in API, in REST API, we can take it, but at backend, MQTT will be used, whether we are going for agriculture based domain or medical domain. Okay. Now, MQTT is protocol. What is this broker? In classical web based applications, you might have seen we use a particular term that is known as server, or we use a particular paradigm that is known as client server architecture. In web based technology, everybody knows about it. Okay. In classical web based technology, classical web engineering, we call client server architecture. In case of IoT, there is no concept of client server architecture. In case of IoT, there is concept of broker publisher, okay, or broker gadget. What is this broker? This is same thing we use in web technology with name server. So you can call it as IoT server. But in IoT, we do not use the term server. If I want to make my laptop IoT server, I will download this software and I will call that my laptop is now IoT server. But it is not technically correct. Technically correct term is that my laptop is IoT broker. Okay, work is same, but name is different. If software is installed in my mobile phone, I will call that my mobile phone is IoT broker. Okay, its working is same like web server, but web server and IoT broker. Okay, these are different technologies. So in IoT, work is same, but at backend broker term will be used. Okay, so whether in whatever application you are working in, on whatever use case you are working. Okay, so what we do, we simply download and install any of these software. So if you will search for free MQTT broker, you will get thousands. So you can see Hive MQ is there, and this one MQTT one is also there. Thousands of servers, Eclipse, Mosquito, MQTT, all of these are completely free and open source. So you can see that free public MQTT broker. But what is meaning of free public MQTT broker? So now we take one very simple example. uh, in case of FASTag, or in case of classical smart home automation, for example, I want to control my home appliances with my laptop. Okay, I want to send signals from my laptop and I want to control uh, different gadgets like refrigerator, washing machine. So obviously in that case, these two devices should be in a common range, whether by Bluetooth or something else, Wi-Fi. Okay. In same way, if we are using some remote control, so remote should be in range of that particular TV or LED, whether we are using infrared or Wi-Fi or whatever it is. If I want to control my TV or washing machine from 500 kilometers away using same laptop, in that case obviously Wi-Fi will not work. Okay, range of Wi-Fi is not 500 kilometers or 1000 kilometers or other city. Obviously, same thing happens in case of remote control. Remote control is having a particular range of IR or whatever technology we are using. I want to send signal from my remote to my TV that is 1000 kilometers away. In that case, what we use internet. If we are using public MQTT broker, it means that MQTT broker is on internet. Okay, I'm repeating this point. If we are using MQTT in our laptop and it is in range of nearby devices, that is okay, smart home automation, smart office automation, but that particular device or multiple devices we want to control from other city, from other country. In that case, your MQTT should be on internet. If MQTT is on internet, in that case there is no boundation of any distance. From anywhere you will be able to control your devices. So you can see MQTT cloud service. So this is known as MQTT on cloud. Okay, so any of these applications you will be able to work with. This one, MQTT. So any of these software you can download and you can install in your system, and you will be able to work with it. Up to now, any question? Up to this point, any question? So that we will, after that we will move ahead. Whatever we have discussed so far, is this clear to all of you? Kindly confirm so that we will be able to move ahead. Because in parts we will discuss, and up to now on only this particular term MQTT and different dimensions, is this clear? And now we will move ahead. Okay, fine. So participants are responding with yes. Now we will see how to use it. See this very carefully, what we are discussing here. How much space, one query is there, how much space is required. Okay, it is in few MBs, it is not in GBs. So initially when we started this topic, MQTT, we are saying repeatedly that it is lightweight protocol. You can see that MQTT protocol provides a lightweight method. In few MBs you will be able to integrate. But if we are working on HTTP, if we are working on other classical protocol, we have to take one full-fledged Apache web server. We need one client server architecture. But in this case, there is no need of any client server architecture. With direct interfacing, we will be able to work with it. Okay, lightweight protocol. And not only MQTT, lots of other protocols available. COAP is also available. Either you can use MQTT or you can use COAP, Constraint Application Protocol. If we want to work with a secured application, highly secured application, one-to-one connectivity, in that case we use COAP protocol. If we want to work with many-to-many connectivity, in that case we use MQTT. So as far as vehicle FASTag implementation is concerned, yes, definitely same. So its mobile apps are available. Yes, definitely. Actually, for mobile phones and desktops, different applications available. For mobile phones, we have Android apps, and for desktop there is separate app. And personal data is also secured. There is no issue. Okay, as far as privacy is concerned, there is no issue. Okay, so if we want to work with one-to-one connectivity, one-to-one secured application, for example, is this screen visible to all of you? Kindly confirm. Screen is visible to all participants. Whether screen is visible to all in chat, kindly confirm.
Yes,
okay.
sir.
Okay. Now see this, how to integrate it. Okay, now if I want to work with this particular protocol, MQTT, many to many relationship, it means from many devices to many devices data will be transmitted. If I want to work with one-to-one connectivity, for example, defense-based application, we want to work with medical domain, medical and health sciences, telemedicine, because data should be transmitted to single medical expert. In that case, we will use COAP protocol, okay, constrained application protocol. If we want to work with vehicular transmission, if we want to work with some particular implementation that is many to many, because many type of vehicles, many type of uh, gateways, different types of fastag, and we are having multiple toll plaza. So multiple toll plaza, multiple toll base stations, multiple devices, multiple vehicles. So this is many to many relationship. We have to work with MQTT. But if one to one secured implementation we have to go for, in that case we integrate COAP. Okay. So this one is the comparison. Okay, so I will share this PPT to all of you at end of this session. I will share this presentation to all of you so that you will be able to go through it. Now we will see how to work on this particular platform. If I want to work with IoT broker in laptop, so what we will do, simply we will download it. Okay, so you can see that this one for multiple operating systems, whether you are having Raspberry Pi, so you can see for Raspberry Pi. If you are using Ubuntu operating system, Linux, Debian, Mac, or Windows. Okay, so what we will do, if I want to make this current laptop MQTT broker, simply I will download 64-bit or 32-bit variant and I will install. After installation of this software, obviously there will be some configuration, there will be some API details, that this one is the URL, this one is username, this one is password of this MQTT broker. Same username, password, same credentials we will use in end devices. For example, with some washing machine, with some refrigerator, with some LED, we want to connect. So in settings of those devices, we will put same credential so that there will be connectivity. Okay, so this is one way. But in this particular case, what is major issue? Major issue is that we will be able to communicate in a specific range, in a range of Wi-Fi or Bluetooth or infrared or whatever it is. If I don't want to use local scenario, local IoT scenario, I want to use MQTT or that particular platform on cloud. I want to communicate with my home appliances from other city. In that case, we have to work with cloud variant of MQTT or IoT broker on cloud for data transmission. And here we need specialized software for creation of dashboards. For creation of dashboard of IoT scenario. Node-RED. Free and open source platform for IoT programming. So many technologies we are naming during this session, so no need to get confused. I will relate these technologies. What is MQTT? That is protocol. That is the base software for data communication. But where we will use, either we will download that software on our laptop, that is fine. But if I want to give its look in GUI dashboard without any programming, okay, if we are downloading MQTT software in our laptop, obviously we have to program, we have to write some scripts, okay, we have to integrate with some programming language. I don't want to work with programming part. As in previous session, last few minutes, there were discussion related to merger of different technologies. Nowadays, we are in the era of multidisciplinary domain, multidisciplinary research. If somebody is from electrical engineering and they are working on robotics, so we can't force that particular scholar to learn Python or to learn Java. We have to give them a particular software in which there is no need of any programming, simply drag and drop. So which is that software? Node-RED is one of that software, which is widely used for IoT programming, IoT and wireless programming, without writing even a single line of code. This is known as flow-based programming part, flow-based programming language. In flow-based programming language, what we do, we simply drag and drop. If I need humidity sensor, I will drag it. Okay, I will put settings in icon of that humidity sensor, temperature sensor, and I will drag, similar to paintbrush. If I need Raspberry Pi will be dragged, and its linking will be done with actual Raspberry Pi. Okay, whether you want to go for simulation or actual deployment. So this one, Node-RED, you can deploy it anywhere. You can deploy it on your local laptop, Raspberry Pi, Arduino board, Android, BeagleBone Black, or you want to integrate it on cloud. So what is purpose of Node-RED platform? If I want to give GUI interface, graphical user interface for my IoT scenario, in that case we use Node-RED. It's different types of deployments we can go for. Either we can deploy it on local laptop. This software is already installed in my laptop. Okay, I will show you that part also. It is available on cloud also. Okay, FlowFuse. So how to work on that particular part? So first of all, I will show you its cloud variant. Okay, so you can see that it can be interfaced with Raspberry Pi. It can be interfaced with low cost hardware. Okay, either you can go for FlowFuse, Amazon Web Service, or Azure. If you don't want to install anything, this is the easiest way to work with IoT programming with MQTT. Okay, rather than using AWS and Azure, I am using FlowFuse. Why? Because even in case of free variant of AWS and Azure, we have to link our credit card or debit card. You might have seen, even if we are registering for free tier of Azure and AWS, we have to link our credit card or any payment mode. In case of FlowFuse, there is no need to link your payment credentials. Okay, simply you can create account and you will be able to work on FlowFuse cloud. So this I have already created, and now you can see open editor, and you will see by which way we can work on IoT scenario. Okay, so this is Node-RED, and you can see that if I want to integrate Raspberry Pi, this is my Raspberry Pi. You can see Raspberry Pi simulator. This one sense head simulator, Raspberry Pi sense head simulator. Without using actual Raspberry Pi, I want to take its all features. I want to integrate its all features. I want to work with weather forecasting. Okay, whatever data is integrated, whatever sensor we have integrated with Raspberry Pi, we want to connect with Open Weather Map. So you can see Open Weather Map is also available. If I want to save data that is broadcasting, that we are managing on internet of things, on IoT, we can store it in a file. You can see write file, read file. I want to store it in a separate CSV sheet. Okay, so whatever data we are sensing, with Raspberry Pi, I want to store in my local laptop. So write file. I want to store in CSV format, HTML format, anything. Okay. Now we will see how to work on this particular part. Simply inject. So you can see that there is no programming, drag and drop. Simply drag and drop. Drag, and this one is timestamp. For example, I'm writing here initiate communication. Okay. Now this one is MQTT, IoT protocol. Okay. I want to send this particular signal to MQTT broker. Connect. You can see that we are connecting it. So this one. So we are not writing any Python code. We are not writing any Java code. We are simply we are simply going for drag and drop part. Okay, this one is MQTT. This MQTT is already given in Node-RED so that we can connect with our devices. For example, this one is some particular device. Okay, any device you can take, any specific IoT broker. So one IoT broker we are taking. Okay, so this one MQTT test client we are taking. Settings, we are creating one username and password. Okay, GK flow, this password we are creating. Port number of MQTT is 1883. Save changes. Connect. Okay, now you will see whatever data we will send, it will be received here. So you can see this one is broker. Whatever username and password we have set, GK flow. Okay, add. What is topic? Any, for example, my device. Done. We are taking that particular device. Okay, now from here we will send some particular data. This is my dashboard. You can see, click. As soon as I have clicked here, you can see that it is showing connected. So I'm zooming it. This one is showing connected. For example, this one is my device 1. In same way, another device we are taking, device 2. This one, deploy. Okay, this one is connected. If we want to put same configuration, we can put, okay, otherwise on single also. So this one is my device, okay, or my gadget. You can put my gadget. Okay, done. Now another topic filter. So this is GUI dashboard. For example, this is LED. This one is refrigerator. This one is some home appliance. I want to subscribe. Now you might be thinking that what is meaning of this subscribe? Okay, this subscribe. Here, this one done, and deploy, connected. So as soon, so you can see that up to now there is single message. As soon as I will click here, now you can see that second message. Now 2 to 3 times I'm clicking and these messages are received here. So what we are doing, so we are transmitting data. For example, I'm sending one message from this dashboard that power on AC, power off that particular gadget, or increase speed or increase intensity of that specific gadget. So it will perform accordingly. Okay, so this one. So what is this subscribe? You can see in case of IoT data transmission, these two terms are used. Subscribe and second is publish. As we were discussing previously also, in case of classical web-based technology, in classical web-based communication, we use client-server architecture. In client-server architecture, you might have seen we use two terms. Okay. In classical client-server architecture, we use terms One is request and second is response. Okay, request response. In case of IoT programming, there is no concept of request response. Okay, I'm repeating this point. In case of IoT programming, we do not use the term request response. We use subscribe and publish. What is subscribe and publish? If any gadget is receiving data, it means it is subscribing data. Okay. If any device or gadget is receiving data, it means subscribing. If some particular gadget or sensor is sending data, so transmission or sending data, it means it is publishing. So if we are having this type of scenario, you can see that this one. So MQTT's broker is there. So temperature sensor is sending data, publishing data to broker, and broker is publishing data to some other device. So same thing. In case of web technology, we use request response. In case of IoT programming, we use publish subscribe. Publish means sending, subscribe means receiving. Same thing you are getting here. On which topic? For example, this one AC. Okay, this one is subscribe topic AC. And now one more I want to take, or simply we want to change it. Deploy, click, and that particular message will be received here. Okay, so currently we are in an online session. In case of offline session, what we can do, in case of offline scenario, for example, multiple devices are there, those settings we have put. So whatever, as soon as we will click here, that particular message will be transmitted to that AC via broker. Where is that broker? So this icon. So we have not installed any MQTT software here. It is already available. So this one, MQTT in, MQTT out. Are you able to understand this part to some extent? No, not fully, but to some extent, are you getting what we are covering here? Okay, so if we want to, in same way, if we want to work with local scenario, so this one is our scenario that is on cloud. Okay, that we have in that we are working on flow fuse. If I want to work on local system, okay, now I'm closing this flow fuse. I will show you on my local laptop. This is command prompt. Okay, this one is command prompt, and you can see that. Is this command window visible to all of you? This one. Now this software we have already installed. Now I will open Node-RED. Okay. So simply we can activate Node-RED for GUI dashboard. Okay. In this way, I will show you a scenario of weather forecasting, weather transmission. Okay. This one, Node-RED. We are opening Node-RED, and you can see that it is working on 127.0.0.1.188.0. So on this URL, we will get dashboard of our IoT. So you can see now we are not working on cloud. This is my local scenario on local host. Okay, this one. Now you can see that this one sense head simulator. This one, if I want to integrate WhatsApp, for example, you have integrated some sensors in Raspberry Pi at some agriculture land, and you want to receive data in your WhatsApp or in WhatsApp of agriculture scientist or in WhatsApp number of farmer. So you will simply drag and drop, drag, open weather map, connect with it. Okay. And if you want to send this data to Raspberry Pi, again, this one, you can see that without any programming, we can work on it, inject. Now this dashboard is created. Okay. So you will be able to work on it. So whatever data, as soon as this button is clicked, data will be taken from that particular sensor. Okay, it will be connected with open weather map. It will be transmitted to WhatsApp, and from that it will move to that specific sensor. Okay, we will see it from scratch. This one is open weather map. Okay, so you can see that this one open weather map, we are integrating it, simply we are dragging it. I want to receive data on my console, simply connect, output, done. Okay, now this one open weather map API key, from remote location we want to sense some data, we want to receive some data, so we need API key. From where we will get this API key? This one is the website openweathermap.org. Okay, for example, we have integrated some sensors at agriculture area, at agriculture land. Okay, and we want to link it with a satellite. So uh, depending upon longitude and latitude of that agriculture land, we want to take some actions. Okay, so for that API, so you can see this one API key. So on which part you want to work? Current weather data, you want to work on solar irradiance data, if your area of research is related to this one. If you need data related to solar panel energy, you want to take data related to road accidents. Okay, so you can see global precipitation maps, each and every data is available. Fire weather data, air pollution, fire weather data, geocoding data, real time data, ultraviolet index, real time data we can sense depending upon longitude and latitude, and it will be transmitted to WhatsApp, it will be transmitted to that device by SMS or whatever it is. Okay, so this API key I have already noted down. So this API key, this API we can generate from here. Okay, so simply create account on open weather map, and this one is API key. So I will put here, double click, API key, paste. For which city? So just Hamirpur, India. Weather details, done. Now deploy, and you will see that at right hand side it is showing this one, clear sky. So this one is data that we are receiving from that specific satellite depending upon this longitude and latitude. So you can see clear sky, wind speed, each and everything. So without placing any sensor physically, by using satellite also we can take some data. Okay, for example, we want to take data from Chennai. Okay, city, country, or if I want to take data from coordinates, done, deploy, and this one is the data we are receiving related to Chennai. Okay, if some participants are near to Chennai, they might be knowing better whether it is correct or not. Okay, missed, and what about the coordinates? What is wind direction, wind speed, each and everything is available. So you can see, if I want to integrate Raspberry Pi, so you can see, for example, I want to integrate Raspberry Pi, this one, Raspberry Pi, rather than this weather station. This one is Raspberry Pi simulator, connect. So we will be able to receive data, we will be able to store this particular data at on screen, on SMS, or in a file. So you can see sense head. First of all, we will see its details. Click. This one is the documentation, open simulator. So you can see this one is simulator. Currently, what is the temperature? For example, 29.2, 81% humidity, pressure 1005 MB. And now deploy. We will see whether it will be saved or not. Now you can see that this one is temperature. At right hand side, you can see it is sensing the temperature. Temperature 20. Okay, humidity this one. And if I change it, now I am changing it. It is 21. This one is humidity. I am changing it. and some directions we are changing some directions also. And you can see that whatever modifications are going on in this particular Raspberry Pi simulator, it is available here. Okay, temperature 21, humidity 85, 1025 pressure, same thing is available. Now I want to change temperature to 18.4. Okay, it is just for simulation. For example, three different sensors we have integrated: temperature, humidity, and pressure. 18.4, 86, and 1030. We will see whether it is available on our dashboard or not. So you can see it is same. 18.4, 86, 86, and 1030. If I want to store this particular data in a file, this particular sensor data we want to store in a file, write file, you can see, drag, connect. In which file? Double click. I want to store in G drive sensor data.txt. Okay, done. In G drive, in my local G drive, automatically a file will be created with this name, sensor data.txt. We will see, done. Okay, successfully deployed. Now I am opening my G drive. You can see that this is sensor data. Okay, this file is automatically created just now at 8:55 p.m. Okay, for example, I'm changing this particular data in this Raspberry Pi simulator, and now we will deploy it. Sensor data2.txt, append to file, done. Automatically this file will be created as soon as I will deploy. Now you can see that currently there is no file with name sensor data2. As soon as I will click deploy, this particular sensor data 2 will be created with readings of the sensors. Deploy, and now you can see this file is created. Okay, this one, sensor data 2, and this one is the reading. Now I can use this data for machine learning. If I can use this data for training in neural network or 2D convolutional neural network. Okay, I can use this data for time series. If I'm working on statistical analysis, we can use this data for LSTM, long short term memory, so that we can go for prediction. So currently we are taking only few readings, but if we are taking that particular data from multiple sources and we want to train it in machine learning model, and we want to go for prediction, we can do it. Okay, so this one is the data. Okay, Raspberry Pi. So by which way you will be able to work on it? There is one query. So do we need to use sensor or directly? So both options are available. There is one query whether we have to use sensors or directly from weather map. Both options available. If you are not having resources, if you are not having sufficient infrastructure to integrate sensors, then you can directly get data from satellite. You can give longitude, latitude. Okay, simply specify longitude, latitude, and it can be done. And there is another query that can we get data this on WhatsApp? Definitely, WhatsApp bot is available. Now this particular software is fully open source. If I want to attach some more segments, now you can see I have integrated Wi-Fi also. For example, I want to integrate Wi-Fi. I want to sense data from Wi-Fi. See this very carefully. We are working on Node-RED. At top right, you can see this button. This particular link is available. This one. I will click here. Okay. Simply I will click here. Manage palette. This is completely free and open source. Without writing even a single line of code, we can integrate multiple modules. Okay, and simply drag and drop. Manage palette. Now install. What I want to install, for example, I want to install Arduino board. So you can see so many plugins related to Arduino. I want to integrate Thinger. Okay, I want to work with Wi-Fi. So you can see Wi-Fi scan. It is already installed. I have already installed. I want to install MQTT. Okay, it is already available. So you can see more than 5,000 plugins. So you can see that more than 5,000 plugins, 5,000 modules available for IoT programming. In same way, if you want to work with, for example, ESP82, okay, ESP8266, it is available. Okay, any of these you can take. Weather, if you want, open weather map is available. If you want to go for Google Map, okay, Google Map is also available. So Google, okay, Google Translate, Google Map, everything is available. And now I will show you one demo related to Wi-Fi. So I'm deleting this simulator, this Raspberry Pi, virtual Raspberry Pi. Okay, now you can see here I have already installed Wi-Fi 370 and scan Wi-Fi.
So screen is not visible,
Screen
sir.
visible. Kindly confirm other participants whether screen is visible or not. Screen visible.
Your your photo alone is coming, sir. No screen is not coming.
Uh,
Your photo alone is coming.
Ma'am, I think that you should pin that particular screen. Kindly check your settings. Other participants having same issue. Any other participant facing same issue?
I
It's
can see the
visible,
screen,
sir.
sir.
Okay.
It's visible, sir.
It is visible, sir.
Visible.
Okay.
It is
Screen
quite
visible,
visible.
sir.
It's visible.
Okay. So, ma'am, kindly pin your screen. I think you are not on that particular screen. Okay. So you can see scan Wi-Fi. So this module, this is not available by default. This I have installed from Manage Palette. So scan Wi-Fi. Okay. Now inject. Inject means start. Okay. Initiate. Initiate sensing. Done. Now I will connect initiate sensing with Wi-Fi scanner. Data from Wi-Fi scanner will move to this file. Second, data will move to output screen. Okay, this one is my output screen. Done. And this particular data I want to store in my wi-fi.txt file. Currently, I'm showing you my G drive. In my G drive, there is no file with wi-fi.txt. As soon as I will deploy from Node-RED, it will be created automatically. Okay, so wi-fi.txt file, if I want to store, overwrite or delete, okay, so simply append. Whatever new signals will come, it will be appended. Okay, store Wi-Fi signals and strengths. Done. This scenario, you can see that this scenario we have created, and it is only a diagram. This is known as flow-based programming. This is known as flow-based programming. Without writing even a single line of code, we are able to work with IoT scenario. We are able to work with wireless scenario. If I want to send this Wi-Fi scanner signals to MQTT, so simply drag and drop. One output will move to MQTT, same output will move to my file, same output will move to my screen. Okay, I can put some details. Okay, whatever data we want to give. Okay, MQTT.1, whatever it is, this one. Now deploy. Now I'm opening my G drive. This one is my G drive, and click here, initiate sensing. Now I'm clicking initiate sensing, requesting, and now you can see this file is created. This file wi-fi.txt is created. Okay, and if I want to see this one, you can see that at right hand side we are getting signals. this one, Gaurav. So these are Wi-Fi hotspots in my range. So I'm showing you my laptop. These are same names which are visible in my hotspot setting. So you can see this one. So I'm connected to this network, my own Wi-Fi. These three other networks, same networks we are getting here. So you can see that. If I want to see this particular data, so you can see that this one, Wi-Fi scanner. So this is the text file that we have created. This one is text file. Okay, so this one, and same strength. What is MAC ID? What is signal strength? So we are able to store these signals. We are able to store this particular data we are getting in a text file. If I want to store in a in HTML file, in CSV file, I want to parse it, it can be done. Okay, or if I want to store it for training in a machine learning model, it can be done very easily. You can see that this is same output. At right hand side also, this is same output. Okay, this one. So any number of gadgets you can integrate, WhatsApp, SMS, or out of any of these. Manage palette, and you can see install, sense. So simply write name and it will be available. So for example, you want to work with this one, 4G, 5G, or anything. Okay, IoT modules. Is this clear to all of you? Kindly confirm. Up to this point, are you getting to some extent? So GUI programming. So simply what we do, see, we simply download and install Node-RED software. As soon as you will download and install Node-RED software, you will be able to run Node-RED with Node-RED command. So simply in your command prompt, you will write Node-RED, and it will give you IP address with port number, and on that IP address and port number, you will be able to program your scenario. Okay, and you will be able to control, you will be able to sense data, you will be able to store that particular file, and we can use it for any purpose. Okay, this one is a simulator. Okay, this one is simulator. As there is one query, is it a simulator or actual IoT device? See, this one is simulator. Okay, if we want to go for actual IoT devices, in that case we can link that particular setting. Okay, so for example, you have integrated MQTT. Okay, so this is not simulator, this is actual broker. If I am clicking here, I am specifying IP address. This is not simulator. MQTT is not simulator. It is actually present. It is actually deployed on cloud, but we are able to use with our own sensors. Now, dear participants, one more platform I am covering very quickly for simulation of our IoT scenario without using physical sensors. First of all, I will explain what I want to do here, what I want to cover here. For example, in my research, I need 50 sensors at particular locations. I need 50 sensors at particular locations, and I want to check whether its integration will be suitable or not. One way is that I will purchase my sensors from different platforms. Okay, on so many platforms sensors are available. Robo is one of that. Okay, Robo sensors. So simply on robo.in you will be able to purchase multiple sensors. But what is major problem? If I want to purchase 50 different sensors, then definitely its cost will be huge. In thousands, I will have to spend. For example, drone parts. I want to purchase drone parts, drone kit. This one. Okay. So you can see that this 3,000, 2,000. So if I need 50 sensors, then huge money is required. I don't want to use physical sensor. Before deployment of my actual sensors, I want to see what will happen if this sensor is integrated and this threshold is set. For example, I'm using carbon dioxide sensor. I want to use hydrogen sensor. Rather than purchasing hydrogen sensor or carbon dioxide sensor or fume sensor, I want to simulate it. My devices provide you that platform for personal application. For personal use, you can go for it. Is this visible to all of you? Kindly confirm. Is this screen visible to all participants? My devices.
Yes.
Now see this very carefully. I am logging into my devices platform. Simply log in, create account and log in. app.mydevices.com, create free account and you will be able to log in. Now I want to simulate some sensor. So one sensor I have already deployed. This one is fire smoke sensor. Okay. So I will start it from scratch. I will take a new sensor. At right hand side, you can see menu. Sensor map. If I click on sensor map, it will give me complete view of Google Earth. For example, at a particular location in Chennai, Coimbatore, in Delhi, I want to put a sensor. Using this sensor map, I will be able to put virtual sensor. And it will give me same type of reading or similar reading that will be given by actual sensor. Okay, so for research implementations, it is very useful. Before implementation, before purchasing your actual sensors, how to see its look and feel. So you can see that sensor map report can be generated at device. Which device I want to add? If I'm having actual sensor, so I can use it as emulator also. I can use it as a simulator as well as emulator. If I'm not using any device id means actual sensor I have purchased and its id I will put. In that case, it will work as an emulator. It will start sensing actual data. But obviously currently I am not having any sensors. I want to use simulated device. Add simulated device. Which device? All simulators of this world are available here. Okay, to be integrated without any cost. So which sensor I want to use? For example, I want to use some air quality sensor. So in category of air quality, hundreds of sensors available. So you can see that this one, if I want to see what is actual price of this air quality sensor, so I'm checking it on Google. Okay, so you can check so you can see 1,600 rupees, 10,000 rupees, 3,200 rupees. So rather than spending this much amount, what I will do, I will simply click here, add device. Okay, so show advanced options, external ID, in which unit I want to collect data, Celsius or Fahrenheit. So air quality sensor. Okay, this one done. This one. Okay, now click here. So where I want to put it. So this particular details we are getting. Okay, signal, battery, this particular signal. sensor map, where I want to put a specific sensor. This one. So this, you can see that this one Digi air quality sensor I have placed here. I want to put it at some other location. So where I want to put, so it will give me that area. Okay, so I want to put it in this Sonegaon. I want to put this sensor, one sensor at this location. I want to put one sensor near to a river or pond. Okay, so you can see this one, sensor map. So without using actual sensor, without purchasing sensor and deploying at a specific location, we are using its simulated way. Okay, so anywhere, for example, I want to see if this air quality sensor is placed in this city, in this district, in this longitude, latitude, then what will happen. Okay, map, satellite view, this is my sensor, and without purchasing it, major part is via satellite, it will collect data. So very effective for research. Now I want to check this data, this one. I want to plot charts. This one, air quality level, battery depletion level, signal. This one, temperature, air quality alarm. Any number of sensors you will be able to integrate in same way. Add asset, you can see, you can add asset, add device, add gateway. You can add a complete gateway also, add simulated device. If I'm giving its actual ID, then from actual device it will start sensing data. Okay, we have to put some settings. So you can see electric meter. So if I want to see its actual price in market. Okay, so you simply write by, so in 2000 rupees, 1800 rupees, rather than that. So you can see all sensors available, which sensor we want to integrate, we want to use. For example, this desk sensor, or predictive maintenance, panic button. In this category of predictive maintenance, which sensors are available. This one. Okay, so add device, or in temperature, this one, ATIM, outdoor temperature and humidity sensor, add device. Okay, this one is the architecture, data, device, image, other details you will be able to use, add device. Okay, now it is available, done, and I will place it at a specific location in sensor map. So currently 0% battery and sensor map. So where we want to put it. So this one is, I want to put it in a specific location. So in Himachal Pradesh. Okay, this one is Hamirpur. Okay, so here on this location we want to place. Okay, which sensor I want to integrate, this specific. Okay, we will be able to work on it. And after that, this one, chart, signal, humidity, battery level, battery depletion level, this one, which type of plot we want to generate. So you can see, without purchasing sensor, a very costly sensor we are able to integrate at a specific location, in a specific city, in a specific state, for experiments. And if we see that okay, our results are fine, and such results can be published also. Okay, so these results you can publish in article, in magazines, in journals, with description of this platform. Okay, nobody will say that it is only simulated platform. So many services available, so many platforms available. Okay, so this dashboard, okay, so you can see this one. So if we want to link it with MATLAB, that can be done. It's linking with MATLAB can be integrated. It's linking with Scilab can be done. Okay, readings displayed. Which type of readings we want to display? Metadata. This one is dashboard, and here you will be able to integrate which sensor you want to attach. So this one. So you can create a complete GUI. Okay, if we want to go for some particular program, some integration, then appropriate programming language can be used. If you want to link it with MATLAB, you want to link it with Python, that can be done. Okay. This one. So what is current temperature? What is current data? Okay, so its complete manual is available. So you can go for, you can go through it, you can analyze its complete details. By programming, we can go for some thresholding. We can go for analyzing a particular value, whether it is above or below that specific scenario. Okay, whether it is above that particular threshold, whether it is below that specific threshold. Okay, if we want to download it, so download data, download sensor data, that can be done. Okay, so you can explore this platform, and its APIs are available for integration with multiple programming languages as far as threshold is concerned. If you want to put some threshold, if you want to put some specific limit, whether it is above or below. Okay, so my motive was to cover different aspects of IoT programming, and to make you aware with different programming platforms, with different interfacing platforms that we can use for our research work. Okay, if you have any query, you can ask any query from participants. Session is open for your queries. I'm sharing my presentation in Cloud Link. I'm uploading this particular presentation, whatever I have covered in this session, by Cloud Link in chat window. Dear participants, link of the presentation is given in chat window. Simply
Thank you, Gaurav sir.
click on this link and confirm is it downloadable or not. Kindly confirm whether this PPT is downloadable or not. Click on this link and download, and kindly confirm whether you are able to download this PPT or not. Simply click on this link and you will get.
I think, sir, some in the chat box they are typing they are not able to download the link.
Okay, just a minute. I'm giving alternate link also. I'm uploading on one more cloud. Okay, multiple options I am giving, so that you will be able to use it. Okay, so if some participants are not able to download, then they can use this link. I'm sharing it. So
I think
one more
someone has
link,
downloaded successfully.
one more link I have shared in chat window. If you can use it in alternate.
Now it's downloadable, sir.
Okay. So session is open for your queries. If you have any query, you can ask.
Okay, you can raise hand one by one, and Gaurav sir can take up your question answer.
And whether these tools are, whether these platforms are beneficial, adaptable for your work. What about your experience? What about you? What about your use case? Whether it will be beneficial or not? If you have any query, you can ask. Any query from participants? Any suggestion related to the content? You are most welcome. Any point of discussion?
Your session was quite comprehensive, sir. It was very well executed. I think the air quality
Hi.
index which you have.
Hello, sir.
Yes,
Yes, sir.
yes, sir. Good evening, sir.
Namaskar, sir. Sir, I have used ThingSpeak, sir.
Ji, thanks.
And in ThingSpeak, I was successfully able to upload the data on the cloud of the ThingSpeak, but I was not knowing exactly what type of protocol it was using.
Okay.
Yeah, sir.
Actually, sir, as far as gadget to gadget or machine to machine communication is concerned, MQTT is used. But as ThinkSpeak is an online platform, so via REST APIs, via HTTP APIs, we access it on internet. So whatever we want to access on internet, we need HTTP. But at backend, we are using MQTT protocol in machine to machine, gadget to gadget communication.
Okay, so ThinkSpeak is also a cloud, no, sir?
Yes, sir. That is a cloud. Okay, that is a
Okay.
cloud for storing data, for management of data. You can store. You can go for plotting. Even you can link ThinkSpeak with Arduino, or uh, you can link with Raspberry Pi.
Okay. So by using Node MCU only, I connected one sensor, and through that I have thrown the data on the ThinkSpeak cloud, and even I was able to get the alert message also
Yes, sir.
on SMS like that.
Yes, actually, sir, these devices, these additional plugins we use for communication. So for data transmission, we have to use Node MCU, ESP8266 for Wi-Fi connectivity. Okay, otherwise we will not be able to use any connectivity. If I want to work with Bluetooth, so obviously we need that specific package. We need that specific sensor.
Okay, so now, sir, one query is mydevice.com. You
Yes, sir.
have just explained in that. Suppose we have received the data from the sensors,
Yes,
and
sir.
we have fixed some threshold value. Now, my question is, if we cross the threshold value, can we send some control signal to the actuator
Yes,
through
sir.
this website?
Definitely, we can do that. In that case, we have to link this particular platform, my devices, with Python or with MATLAB or any third party platform. Even you can link it with Node-RED also. So as far as action taking is concerned, decision making, action taking, threshold matching. For that, we need third party platform. Either you can use Python or you can use Node.js or any programming platform. But it is better to use Node.js or Node-RED because it is GUI based, completely graphical user interface. No need to write any script, no need to write any code. Okay,
Okay.
because nowadays you might have seen that students or scholars from mechanical, from electronics, they are working on such scenarios, and we can't expect that everybody must be conversant, must be proficient in programming part.
So if we use device.com and Node-RED, then there is no need
Yes,
to write the program. Directly we can
that,
generate the actuator signals
yes,
also.
yes, sir. That particular linking can be done.
Okay, thank you, sir.
Any other query? Any?
Hello, sir.
Yes, sir.
Sir, by any chance, have you worked on SDN simulator?
Yes, sir. SDN on software-defined networking, Mininet.
Yes, sir. So Mininet Wi-Fi supports 6LoWPAN simulation.
Yes, yes, sir. Yes, sir.
Uh,
So,
so
so actually, in that case, we work with Python or Java also that is integrated. So it depends on that particular scenario. So what is the use case on where you are using SDN?
Sir, actually, I'm working in this SDN-based IoT network implementation where
Okay.
I work with Mininet Wi-Fi. So right now, I'm planning to move towards AI/ML integration of this one.
Okay.
So basically, like I want to know how to move or how to configure this Mininet Wi-Fi 6LoWPAN simulator with AI/ML.
Okay. You can mail me that particular specific case scenario. You can mail me. I will tell in Mininet how to integrate it. By which way we can move ahead.
Okay, okay, sir.
Any other query? Any other participant who wish to communicate?
Hello, sir. I have one query. Like you have connected the sensors through simulator. So these sensors are giving us the live data, like AQI data, if we
Yes.
have
Yes.
connected.
Yes.
But suppose like if we have a data, if we need a data from a particular vehicle, so for that we need a means actual sensors we need to
Ye-
put in.
Yes, ma'am. In that case, we need actual sensor, and you might have seen in my devices, external device ID we can put. Okay, we can specify the settings, and in that case, it will start sensing real-time data.
Sir, actually, I have created a one device for individual vehicle emission measurement. In that, I am measuring CO and CO2 values. I have used a PM 2.5 and MQ9 sensors in it, and I have taken the readings. I have connected it to Blink device as well, Blink
Okay,
IoT
okay,
application.
okay. Blink IoT you are using, fine.
Yeah, but sir, the problem is that I'm getting the live data, but I need data. Like suppose my vehicle traveled for 1 kilometer, so from that particular point to the end point, I need the calculation of the emission values. So how could I do that?
Okay. So you are using some algorithm. Are you using some algorithm related to trajectory also, like analysis?
Yes, I have used the algorithm for it, but I am getting only the values, not the addition of from starting point to end point values in it. So
Okay. So, ma'am, in that case, you can integrate some third-party module that can detect longitude and latitude, either longitude, latitude, or timestamp. That after every 1 second or after every 5 seconds, it is taking data. Or with timestamp, you can integrate longitude, latitude, so that we can go for analysis of the movement also. So from which location to which other location it is moving, and at each point, what is the reading.
okay, sir, we'll try that also.
You can try, and if you face problem, you can mail me. I will try to see what is the issue, and I will try to suggest some solution.
Yes, sir. Thank you so much. Thanks a lot. Sir.
Thank you.
Thank you.
Any other participant?
Sir, I want.
Yes, sir.
Hello, sir.
Yeah, yes, sir. Please.
Sir, I'm facing a problem to connect the ESP32 cam. Sir, I collected different disease images from real time data, and
Okay.
sir, collected images from Google Drive, but I want to create a API or a REST for detecting disease types. That
Okay.
means I
It means
want to
you.
uh, that means I want to apply the ML algorithms on the collected images.
Okay. Sir, for this case, you can use a platform that is Hugging Face. On Hugging Face, you will get so many APIs, free APIs from corporate giants. So, have you ever explored this platform, Hugging Face? I'm sharing its link in chat window.
Okay, sir.
So, uh, you can use it. Okay, so what you can do, you can integrate your data set with this platform. Hey, on this platform you will get thousands of corporate models. For example, for my research work, I want to take a model of Facebook or Meta or WhatsApp.
Okay.
Okay, so
Ji.
it's a open source model is available, and I can fine tune that model with my own data. I can integrate my own data, and then it will be giving results as per my own data set depending upon my training data. So you can explore this Hugging phase.
Okay, sir. Thank you, sir.
Well, I think, is there anybody else
Any other query from
who have a
participants?
query? Any other participant? I think, sir, the session was very excellent and very comprehensive. Thank you, sir, Gaurav sir,
Thank you.
for your valuable and very hands-on session on the data acquisition and processing. Now we will be meeting tomorrow at 5:50. Okay, so I request all the participants to kindly join using the email ID that you have registered with on Atal portal. Some of you are using some other email IDs and we have to let you in the meet manually. So the link will be shared on the WhatsApp and on the registered email IDs tomorrow. Kindly be ready at 5:50 as sharp at 6 we will be starting with the second